Hi everybody, welcome to my class of image processing, and this is the 11th class, and today I'm going to talk about the object recognition. What I'm going to talk about today is not about my research. This is about the other researchers' study, YOLO. This is a very famous study and very famous paper in object recognition. So, object detection and recognition is divided by two periods, before YOLO and after YOLO. So this is very famous and very important paper. So today I'm going to present about the contents of this paper. Okay, this paper was published in 2016 by Joseph Ledmon and his colleagues. Okay, we are about to finish. There are more subjects planned, but I think it is very difficult to continue this class. Maybe if I have some more time, then maybe I can show you how to implement YOLO in Core App next time. But I can't sure about that. So just I wish. Okay. So first, you need to understand what the object recognition is. Object recognition is a localized and recognized object image. So, localized means that we need to know where it is. So, where the object is. So, okay, there is an object here. Okay, there is another object here. That is the localization. We need to know the x and y coordinates and the width and height. That is localizing. Recognizing is to understand what or who it was, who he was or who she was. We need to know the persons. Okay, whether this is the person or animals or things, or maybe we can distinguish who is he or who is the person, the name or any other specific things we need to recognize, we need to know. That is the recognition. So this was the concept of the object recognition. And also there's one more thing you need to know before we start. That is the concept of training and inferencing. So there is two phases in machine learning, especially deep learning. We have a training phase. Training is the training model from the prepared data. So we have lots of data, and we know what it was, what it is. This is the person, and this is the dog, and this is the cat. We know already the answers. So with this data, we can train our models. That is the training phase. And the inferencing phase is utilizing our model to get the output from the unknown data. So there is an image, we do not know what it is, and just put this data into our model and get the output. That is the inferencing. Okay, so that is the two phases, training and inferencing. And there's one more thing, test. Test is to check whether the inferenced output is correct or not. So if it is the testing, during the testing phase, if the inference result is good, then okay, we say that this trained model is very good. This model is trained very well. And otherwise, okay, we need to train once again. Well, yes, that is the testing phase. Okay, and one more thing you need to know is we need to separate the data for the training and testing. Because if the data are mixed together, and then testing result does not guarantee for the good result. Because it is already mixed. If the testing data is already used in the training phase, then the testing doesn't have much meaning. Okay, so this is another basic concept for object recognition. Okay, then we can start. Okay, the object recognition is divided, I said, divided before YOLO and after YOLO. before YOLO, there are lots of algorithms, but just I want to explain one algorithm, sliding window. This is the algorithm to fix the size of the object to detect and put the sub-image in a sliding window to neural network. Okay, so which means there is a box here. Okay, so we want to recognize object in the image, and we do not know where it is. So we just put one box here and move this box step by step and recognize all the sub windows, all the images in the sub window. Okay, this window. Okay. Then we may recognize, okay, then if the box comes here, then we may recognize the person, this girl, correctly. And if this box moves to the right, a little bit more, then we may able to recognize the dog. Okay, there is a problem. With this method, it is possible to recognize all the object correctly, but it takes too much time because we have to check lots of images, lots of sub windows. Okay, sub images in a sliding window. So it takes a lot of time. Okay, so we can do it, but it takes lots of time. And another problem is it is difficult when the object sizes are unknown. So here I assumed the object has this shape and the size, but it could have a different shape because we do not. There are lots of cases. There could be a person with a very small size. Okay, and if we want to detect the very small size person, then we have to make another window, very small window once again. So if sliding step is 1 pixel for this size of image, then we have to test lots of times required, and this is multiplied by the shape of this box, this window. So it takes lots of time. Okay. And YOLO is pretty different, and YOLO's concept is inferencing the single activation. So we do not want, this is, here I say activation is, you may understand this as an inferencing. So just the inferencing is takes only once. Then we can get multiple outputs. Okay, there is a girl here, dog here. Then this is not dependable to the object size. Oh, that's great, isn't it? So how it is possible? The input of this YOLO network is the whole image, and then output is going to be like this. So dog, okay, place of the dog, position of the dog is here, and the size of the object is here, and then it looks like dog, and the possibility to be dog is 0.9. So this is this is one example of output for this image. Okay, so the network is trained to make this output directly. That is the basic concept of the YOLO. Sorry, this is not the slide window. Okay. Okay, I already explained this. And the output box, so there is an input and output of YOLO. You see, their input of YOLO is whole image, and the output is the box. Okay, this is the girl, this is the dog. So we have the output boxes. Okay, output is going to be in this shape: box info and class information, and box information and class information. So if we formalize this output into the neural network style, then we have this output. Okay, and there is lots of cells. So here, for example, you can divide these cells into this image into 9 cells. So you can divide this image into 16 cells or 6 cells, is up to you. And here, for example, is we divide this image into 9. Okay, then each box in a cell represents an object whether whose center is in the box. So, for example, there is a goal here, then this goal should be detected at the cell number 4, we assume. So, we are going to train this model, this network, so that this train to make the output of this goal at the cell number 4. Okay, and so for each cell have the output of box information and class information. So you may understand that we divided this one image into 9 boxes, and each box may has the one output of box information. Okay, so for example, there is a number 5, box number 5, cell number 5, and this cell number 5 has one box of an object information. So here you have to, you do not, I wish you may not misunderstood me, that this box is different to the cell. So the box could be larger than this one cell, but this number 5, box in the number 5 represents the object whose center is in the box. Okay, so for example, just let's look at the cell number 1, and if there is an object in cell in number 1, then which means the center point of the object is cell number 1. Okay, then from the center point of the box, if we know the width and height of the object, then we can make a box. We can draw a box around the object. And then we may say, okay, this is the girl. So if in one box information and object information, then we say this is one anchor, and there are 5 plus number of class outputs existed for a cell. Okay. First information is 0 or 1. This is if this is 1, then which means the object exists. So there it could be 0. For example, in the box number 3 here has no object. So in that case, this value is going to be 0. And if the first value is 0, then all the other information doesn't have meanings. Okay. And there are other informations: box center X, box center Y, and box width and box height. And there are 3 other bits, 3 other nodes. Then this is about the class of the object. If this is 1, then object is a girl. If this is 1, then the object is dog, and if this is 1, then the object is a cat. So in the inferencing phase, this could be 0.5 or 0.667 or something like that. But if during the training phase and for the target data, this is going to be 0 or 1. Okay. These boxes could be existed in many in per cell. So, for example, there could be 2 boxes in one cell. Yeah, because there could be 2 objects in one cell, isn't it? So, if a box is big and objects are small, then there could be many objects. So, first object could be a person here, and another object is going to be here sky in here. So with this reason, they designed the YOLO output in this way. In one cell, there could be 2 or 3 boxes. Informations could be existed. Okay, the contents are the same. So, just making our explanation simple, let's assume that there is one single box per cell. Okay, then the number of outputs is going to be 72 because we have 9 cells and 9 boxes, right? So 9 cells, 9 boxes here, and then for one box we have 8 informations here. And 5 information is very necessary, and the other 3 is going to be the class information. Okay. Here, the XY coordinates are going to be relative coordinates from the center of each cell. Okay. And the height and width are squared root. If the height of the box is 25, then it's going to be converted into 5, because if for the big boxes, the small error does not have much meanings. But for even for the same size of the error, but the object size is small, then it's going to be very important error. Okay, so that's why they did the square root for the height and width. And then all the values here are going to be normalized between 0 and 1 for to input and output this is not input, sorry, to train the networks. Okay, and you need to understand that this output is just to explain easily, and the real output shape is one-dimensional array. And then there is an input. Input is non-divided input. So this is there is a numbers. This is just for the output, and for the input is the whole image. So whole image is going to be put into the network, and the output is going to be one-dimensional long array. Do you understand? So, and there is no structural division for the parts of inputs and parts of output. So it is just training the network to make a separated output. So we assume that inside, we just wish the inside the network may separate whole image into the localized outputs. So if there is an output, object is found here, then which means the cell number 1 has an object. If there is an output here, and the value of objects exists here is close to 1, then which means this is number 1, 2, 3, 4, 5. So number 5 has an object. So this is how the networks works. Okay, neural network is to be trained with a pair of data, input and targets. So the target data is just like this. Okay, and during for the target data, we just have 2 boxes here, because if there is only two objects here, then we have 2 targets are available. All the other values are zeros. Okay. Here, the value of x and y with height, goal, dog, cat informations has bar and is missing because these values are ignored during the training phase. So they designed their own custom loss function to make this. So in their loss function, they multiplied the object exists output and the real loss output, then if the loss all the loss informations all the errors by the x and y coordinates are going to be ignored if the object exists value is going to be 0. Okay. And they also put the that is here weighted loss, and also they developed other custom loss functions, xy distance. So they calculated this loss to x and y together, xy and y coordinates together. So it is possible to put it is possible to calculate the x errors and y errors independently. That is the basic option of the most AI framework, but they developed the custom loss function, so they calculate the xy coordinates together. So, and also they calculated the width and height distance together. So I say this is distance, not the difference, because they calculated in this way. There is a square root, which I explained in previous slide, and they calculate the difference and squared and some they added to. Okay, that is which means the distance between using the width and height. And also they put the custom learning rate, and which may decrease over epochs. So this is the sentence which explained about the epoch decreasing, and they initially the epoch is like this, and they put as the epoch increases, then as you see, finally the learning rate becomes 0.000001, right? Okay, so we are about to finish. This is the inferencing. The inferencing is to put the data, one data to train the model. Okay, there is one input data. Okay, and we want to put this data into a model, and we may get this output. So this is going to be different to the target, but this is still have important information. So this is the output. And what we have to do here now is to separate more important information and the less important information. So there are many boxes. Our informations are appeared here, and all the boxes are assigned to the cells. Cell number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we have lots of boxes, and I draw only 4 boxes, and as you see, some boxes are overlapped. And here we applied the authors of this paper applied the non-max suppression, and to eliminate the overlapped boxes. So if the overlapped region is more than 50% or 40%, this is up to the implementer, and then they remove the algorithm will remove the overlapped boxes. Then we may get the cleared and corrected result. Okay, YOLO also has the limitation, and this is difficult to recognize small objects close to each other, because the number of objects in one cell is limited. Yeah, I explained it as if the number of boxes are in one cell is just one, but in generally, 2 boxes are allowed to be exist in one cell. But still, there could be more objects in one cell, so in that case it's going to be difficult to recognize. And the box information, box width and height ratio is highly dependent to the box ratio of training data. So if all the data of the person is all the standing status, then the person in the testing data is seated position, then as you may expect it, the ratio of the person is going to be completely different. If the person is sitting, then it's more like a square shape. But if our person is standing, then it's more likely the rectangle is longer in the vertical axis. Then it's going to be difficult to recognize. Or maybe a person is not just standing, but it's about to fall, and in 45 degree, then the box ratio is going to be more likely to be a square. Then it's going to be difficult to be understood as a person. So that is another weak point. Of course, if there are lots of training data and lots of shape, lots of cases, cover all the cases of the ratio of the person and the object, then it's not a problem. Okay, today I explained the concept of object recognition and the contents of YOLO. And YOLO is a famous and fast and accurate algorithm, but still could be developed better. There are chances for you to develop new algorithms better and better. Okay, thank you for your listening, and see you next class.